So in this session, we are going to talk about polynomials. Let's first see that what polynomial is actually. So polynomial is actually an expression which is in fact a combination of constants and variables. Now the follow from this is what is a constant and what is a variable. So when we talk about a constant is something which has a fixed value. For example, all the whole numbers, all the natural numbers, fractions, integers, everything is a constant. So -5, +4, 5/4, all the rational numbers, let's say √3, etc. All these numbers are constant because they have a fixed value. But when we talk about a variable is something which can take any value. For example, the most common variable which we use in our questions is x. We also have variables like y, z, a, b, etc. So all these are actually variables which does not really have any constant value. All right, so polynomial is an expression which is a combination of constants and variables. Now, let's talk about the types of polynomials. So there are two ways to classify the polynomials. So the first way is based on the number of terms which the polynomial has. So we have the following types of polynomial. One is called monomial. Another one is called binomial. Another one is called trinomial. Then we have quadrinomial, etc. So this is based on the number of terms which it has. For example, monomial. Monomial means that the polynomial has exactly one term. So for example, just 5, this is a monomial. Having an x is a monomial. Having, let's say 3y is also a monomial, just like this. Binomial means it has two terms. So it can be 5 plus, let's say, x. Then it can be, let's say, x plus y. Then it can be, let's say, 2 minus x. So we have 2 minus x over here. That is also a binomial, etc. Trinomial likewise is three terms. For example, 2 plus x square, or 5 plus y plus z, etc. Quadrinomial has four terms likewise. So 1 plus x plus y plus z. This is a quadrinomial, and etc. Now we can also classify polynomials based on the power which it has. So polynomial based on the powers is defined as we have a constant over here. Then we have a linear term over here, linear. Then we have quadratic. Then we have cubic, etc. Now constant means the degree of the polynomial is 0. For example, we have 5. So 5 is a constant polynomial. Why? How its degree is 0? Because 5 can be written as 5 times x raised to the power 0. And x raised to the power 0 is nothing but 1. And 5 times 1 is nothing but 5. So the degree over here is 0. So it's a constant. Let's talk about linear. Linear means the degree is 1. So 5x is a linear polynomial. 2y is a linear polynomial. 3z is a linear polynomial. Likewise, quadratic is the degree is 2. For example, 2x square is a quadratic. 2x square plus 7 is also a quadratic. 3y square minus 5, this is also a quadratic. So all these are quadratic, means the degree is 2. Likewise, cubic, 3x cube. 3x cube minus 4x. 3x cube, let's say, plus 2 plus, let's say, 5x. This is also a cubic. And likewise, there are various other terms. All right. Let's not talk about some operations. Let's not talk about another difference, another term which we will find in polynomials. It is like and unlike terms. So what are like and what are unlike terms? For example, if you have terms like 5 and 2, these are like terms. Why? Because both are constants. If you have terms like x and 4x. These are like terms because both are variables and both have x in it. For example, if you have x square, 2x square, and 3x square, this is like term. These are like terms. So what will be unlike? For example, if you have 5 and x, this is unlike. If you have x and x square, this is unlike. If you have x and let's say y, this is unlike. So anything which is similarly looking basically is like term, and these terms, like, they are different based on either constant or variable, or maybe the degree is different, or maybe the variable is different. Just like these examples, these are all unlike terms. All right, so let's talk about some of the operations in polynomials. So we are talking about operations in polynomials. So the operations will be addition, subtraction, and multiplication. Let's talk about addition first. So addition is possible, or addition or subtraction, this is possible. In fact, I will write subtraction as well. So addition or subtraction is possible only between like terms, not unlike terms. So let's suppose you want to find out 2x plus 3y. You cannot really add it because they are unlike terms. You want to find out the addition between x and x square. Again, not possible because unlike terms. So addition or subtraction is only possible between the like terms. So how it has to be done? So the first example is, let's say you have to add 5x and 2x. What would be the addition be? So since we have 5 times of x and 2 times of x, so what we do is we add 5 and 2 and the x remains as it is. So 5 and 2 addition is 7 and the x remains as it is. So this is the addition of 5x and 2x. That ways we have, let's say, 5x plus 2y plus 7x plus 3y. What is the addition of this? So x and y are unlike terms, so we cannot add it. But 5x and 7x, these are like terms, so we can add it. So 5 plus 7 is 12, so this results in 12x. When we talk about 2y and 3y, these are again like terms, and 2 plus 3 is 5. So 2y plus 3y will be 5y. So this is the addition of these terms. All right, let's take another example of subtraction. What is 5x square minus 2x square? So these are like terms, and we do 5 minus 2, which is 3, and x square remains as it is. So this is the subtraction. Let's take another example. Let's say we have 5x square plus 2x plus 9 minus 2x square plus 9x plus 4. So what is the subtraction here? So first of all, we have to open up the brackets. So the first term remains as it is, 5x square plus 2x plus 9. This first expression is as it is. Then we open up the brackets of the second one. So minus goes inside, and the sign of all the terms will change. So when it changes, we have minus 2x square minus 9x minus 4. So from here we are getting 5x square minus 2x square is 3x square. 2x minus 9x. So 2 minus 9 is minus 7. So minus 7x. And 9 minus 4 is 5. So this is the subtraction of this polynomial. Let's take another example. So we have 5x cubed plus 2x plus 91 minus 7x square plus 11x. This is 11x plus 41. What is the subtraction of this? So again, let's open up the brackets and take the minus sign inside. So we have the first expression as it is, 5x cubed plus 2x plus 91 minus 7x square minus 11x minus 41. So 5x cube, we don't really have any other cubic term here. So 5x cube will remain as it is. All right. We don't either have any other square terms. So minus 7x square remains as it is. And now over here, 2x minus 11x. So 2 minus 11 is minus 9. So minus 9x. And over here we have 91 and over here we have 41. So 91 minus 41 is 50. So we have 50 over here. So this is the required subtraction of this polynomial. So in this way, we can subtract and or add the polynomials, but keeping in mind that this is only possible in like terms and not unlike terms. All right, let's now talk about the multiplication of the polynomials. All right. In the first part, let's talk about the multiplication of mono with mono, means monomial with monomial. So let's say we are talking about one monomial is 5, another monomial is, let's say, 2x. So what is the multiplication of this? In order to multiply, we will, when we multiply, so we multiply the constant with a constant and a variable with a variable. So in this case, there is only one variable, so we'll write that as it is. And when we multiply a constant with a constant, so 5 times 2 is actually 10. So we get 10x over here. Another example is, let's say we want to take 9 and 4x. Let's say it is 4x square. So in this case, the x square remains as it is, and 9 times 4 is 36. So here we have 36x square. Let's take some examples of mono with bi, means monomial and binomial. Let's suppose one monomial is 5x, another binomial is 2x square plus 5. So how are we going to multiply this? First, we'll multiply 5x and 2x square. We can write it separately as well. So 5x times 2x square. Then we have a plus sign in between, and then we multiply 5x and 5. So we have 5x over here and 5 over here, and there is a plus sign in between. Now, once again, these are monomial and monomial. So 5 times 2 is 10, and we have to do x times x square as well. And over here we have 5 times 5 is 25, and the x remains as it is. Now here we'll talk about a rule of exponents here. So if we have any two variables which are multiplied and the base of the variable is same, let's say in this case is x, and we have to multiply it with the powers a and b, then that multiplication will actually be, we write the base and we add the powers. So that is the rule. So likewise, if we want to multiply x and x square, so as per this formula, it will be x raised to the power 1 plus 2, which is x cube. So over here, we will get 10x cube plus 25x. So this is the answer. Let's talk about another example. So we have 9 times 2x plus 7. So likewise, first 9 is multiplied with 2x. So we have 9 times 2x plus, then 9 is multiplied with 7. So 9 times 7 is 63. Now 9 times 2 is 18. So we have 18x over here, and plus 63 remains as it is. So this is the answer in this case. All right, let's talk about monomial with trinomial. So we have mono and we have tri. So the procedure remains as it is, just one step is increased. So let's suppose we have 2x square as monomial and we have 3x. Let's say we have 3x square minus 4x plus 7 as trinomial. So what will be the answer for this? So first step is we multiply 2x square with 3x square. So let's write it separately. We have 2x square over here and we have 3x square over here. Now next is what will be the sign? Sign will be minus because here we have minus. So we write minus. Then we multiply 2x square with 4x. So we have 2x square over here and we have 4x over here. This is the second term, and next term we have plus sign over here. So we have plus with 2x square is multiplied by 7. So we have 2x square over here and 7 over here. All right, now 2 times 3 is 6. So we have 6. Here we have x square times x square minus 2 times 4 is 8. Here we have x square times x. Then we have 2 times 7 is 14. And here we have x square. Now, just like the rule which we just studied above, that whenever we have, I'm talking about this rule. So whenever we have the variables in multiplication and there are powers, then the powers actually add. So let's apply the same rule over here. So we have 6 raised to the power 6x raised to the power 2 plus 2 minus 8x raised to the power 2 plus 1 plus 14x square is as it is. So here we have 6x raised to the power 4 minus 8x cube plus 14x square. So this is the required solution. All right, let's talk about now binomial with binomial. So here, just one addition to what we were doing earlier. Let's suppose the first binomial is 2x plus 3, and let's suppose the second binomial is 9x square plus 2x. So 9x square plus 2x, we have to multiply it. So first, we multiply 2x with 9x square. So this gives us 2x times 9x square. Second, we multiply the 2x with 2x. So here we have 2x times 2x. Now the same procedure applies with this term. So we multiply 3 with 9x square. So we have 3 times 9x square plus then we multiply 3 with 2x. So we have 3 times 2x over here. All right, so this becomes 9 times 2, 2 times 9 is 18. We have x times x square over here. Now 2 times 2 is 4, then we have x times x. 9 times 3 is 27, we have x square. And 3 times 2 is 6, and x is as it is. So x times x square will be x cube. 4x times x is x square. Then we have 27x square plus 6x. These are like terms, so we can add these. So this becomes 18x x cube plus 4 plus 27 is 31 x square plus 6x. So this is the required answer. And the last combination will be, we are talking about binomial with trinomial. So this will be mostly the same. So we have, let's suppose, binomial as 4x minus 9 and another trinomial as 9x square plus 7x plus 4. So in the first case, we take 4x. 4x is multiplied with 9x square. So here we have 4x times 9x square. Then we write plus sign. Then we have 4x times 7x. So 4x times 7x plus then the another way will be 4x times 4. So this will be the another multiplication. Now we write the other part. So we take minus 9 now. So we have minus 9 times 9x square. Then minus 9 times 7x. Then minus 9 times 4. So this will be the complete multiplication. So let's simplify this. So we have 9 times 4 times 9 is 36, x times x square, plus 4 times 7 is 28. Then we have x times x. Then we have 4 times 4 is 16. So we have 16 x's as it is. Then we have 9 times 9 is 81 x square. Then we have 9 times 7 is 63 and x is as it is, and 9 times 4 is 36. So this becomes 36 times x cube plus 28 x square plus 16x minus 81x square minus 63x minus 36. Okay, so this will remain as it is. There is no other cubic term here. We have two square terms over here. So these are like terms. We can subtract it. So 28 minus 81 is minus 53 and x square is as it is. Then again, we have 16 and 63 as 16 and minus 16x as minus and minus 63x as like terms. So 16 minus 63 is minus 47 and x, and then we have minus 36. So this will be the answer, final answer. All right, so this is about the addition and multiplication of the addition, subtraction, and the multiplication of the polynomials. Of course, if we cannot talk about division because division won't be a polynomial. So if we say that we have, let's say 2 over x, so 2 over x is not a polynomial. So division doesn't really come inside polynomials. Okay, let's talk about another property of raising of powers to powers. What I mean from that is, let's say we have x square raised to the power 3. What is the solution of this? We know that x square times x square is, we take the base as common and we add the exponent, so we have x raised to the power 4. But what about this case? So whenever we have the powers raised to power, we actually multiply those two powers. So this will be 2 times 3. So this will be x raised to the power 6. But why is this happening? So let's break this x square raised to the power 3 in some pieces. So x square raised to the power 3 means this complete thing is appearing 3 times in multiplication. So it means x square times x square times x square. So 3 times this is appearing. And as per this rule, we can write this as x raised to the power 2 plus 2 plus 2, which is nothing but 3 times 2, which is nothing but x raised to the power 6. So that's how we are getting x raised to the power 6 over here, by multiplying these two exponents right away. So that is the rule. So let's take a couple of examples on this. Let's suppose we are supposed to find x cube raised to the power 6. So what is the solution? So we multiply 3 and 6. So we are getting x raised to the power 18 over here. So x raised to the power 18. Let's suppose we have to find x square y cube raised to the power 6. Or let's suppose the power is 5. Now what is the solution of this? So we have, this can be broken down as x square raised to the power 5 and y cube raised to the power 5. So this means that we have x times 2 times 5 is 10. Then we have y raised to the power 3 times 5 is 15. So this is the solution in this case. There's another rule of exponents which is with division. So what is that? For example, we have x raised to the power 5 over x square. Now what is the, how can this be simplified further? Now this means that this can also be written as x raised to the power 5 times Whenever we take this term in numerator, the power sign of the power will change. So the power will be -2. And now we can use the rule which we already know. So base is same. So the power in this case will be 5 plus of -2, which means 5 minus 2, which is 3. So the direct rule for the division is we subtract the powers, and for multiplication, we add the powers. So this is a very simple rule to remember. Okay, let's do some operations with multiple variables. So the first one is we have 5x square plus y square times 2x plus 3y. All right, so when we talk about this, we'll do the same procedure. First of all, 5x square times 2x, this is 1. Then we have 5x square times 3y, 5x square times 3y. Then we have 5x square times 2x. And next we have 5x square times 3y. So over here, 5 times 2 is 10, and x square times x is x cubed. 5 times 3 is 15, and x square times y remains as it is. We cannot really multiply it any further. 5 times 2 is again 10, and x square times x is x cubed. 5 times 3 is 15, and x square y remains as it is. Now this x square, this term and this term are like terms, and these two are also like terms. So this means that actually there's a correction required here, because over here we won't really have 5x square. So this won't come here, and this also won't come here, because we have to multiply it from the other part. So we have y square times 2x and y square times 3y. So we have y square over here and y square over here. So this particular term, these particular terms won't come. Let's modify this. So we have 2xy square over here, and we have 3, and y square times y is y cube. So this becomes 10x cube plus 15x square y plus 2x square. It's not 2x square, it's 2xy square plus 3y cube. So this is the final answer, and this cannot be simplified any further because every term is unlike term. All right, let's talk about another example. So in example 2, we have 5x square times y raised to the power minus 4 times 2x cube times y raised to the power 6. So all the terms are in multiplication. So first off, 5 times 2, this is 10. Then x square times x cube. Then y raised to the power minus 4 times y raised to the power 6. So this will become 10 times 2 plus 3 is 5, and here 6 minus 4 is 2. So this is the answer. Let's take another problem. In this case, we have 27x square y raised to the power 4 over 3x raised to the power 4 y square. All right, so 27 over 3 is 9. And we have x square over x raised to the power 4 here, and y raised to the power 4 over y square here. So x square over x raised to the power 4, we read the rule that we subtract the powers, and here again we subtract the powers. So here we have 9 times x raised to the power minus 2 times y square. So this is the required answer. Let's talk about another term, another example. So we have example 4. 3x square y cube raised to the power minus 2. So again, we can rewrite this as 3 raised to the power minus 2. Then we have x square raised to the power minus 2. Then we have y cube raised to the power minus 2. 3 raised to the power minus 2 is nothing but 1 over 3 square. X raised to the power, this is 2 times minus 2, which is minus 4. And here we have 3 times minus 2, this is minus 6. So 1 over 3 square is nothing but 9, and x raised to the power minus 4 times y raised to the power minus 6 remains as it is. So this will be the required answer. So in this way, in this session, we talked about polynomials, and then we talked about how the multiplication of the polynomials need to be done, addition of the polynomials, and some other rules about the exponents as well. So that's it for this session.